Last month, we ran the first of 7 workshops covering supervised machine learning in Python with Scikit-learn. Here's a 3-minute recap. Our goal is to predict wine quality on a 1 to 10 scale using historic data from 1,500 bottles, which includes an average score from wine experts, whether the wine was red or white, and several production process values that we'll shortly see. We'll load data, explore relationships, and build a simple regression model using pandas, NumPy, Matplotlib, Seaborn, and Scikit-learn. Let's get started. First, we use pandas to load the wine quality CSV file to see what we're dealing with. The notebook shows us quick distributions for the number columns and frequencies for the categorical variable, wine type. We can get broader numeric summaries using the describe function. Next, we use the Seaborn pair plot for some of the variables to explore potential relationships. The top scatter chart in the first column shows us alcohol content against quality score for the 1,500 wine bottles. As alcohol goes up, for both red and white bottles, average quality score from the experts also tends to increase. We can explore linear correlations for all the numeric variables with the core function, and then create a heat map to visualize their intensity. Again, we see that alcohol content has one of the strongest positive correlations with quality score. We can use this observed relationship to build our first linear model. We want to follow our machine learning approach that uses a subset of the data to train or build the model, and the remaining data to test that model and check its performance. The train test split function from Scikit-learn speeds up this process, randomly assigning 75% of our dataset to the training set and 25% to the test set. To build our linear regression model, we initialize a linear model object and then train the model by passing in the training data and their known quality score labels, the thing we want to predict. This fitting process gives us an intercept and a beta coefficient that form our linear prediction equation. It is a simple linear model, but we could put in any value now for alcohol content, and the model would return an estimated average quality score. Let's take a look at the predictions in the second column against the actuals in the first column. You can see right away that some are fairly close and others aren't. Notice that we made our predictions passing in the test data, not the training data, so that we can feel more confident on how the model will perform on new data. Turning to model evaluation, we take a look at R-squared, one of the standard metrics to see how our model is performing. R-squared values can range from 0 to 1. A higher value indicates that more of the variation of what we are trying to predict, average quality score, is explained by the input value, alcohol content. The predictions from our test dataset reveal an R-squared value of only 0.37. That's pretty low, indicating that our simple model to predict quality score from alcohol content alone doesn't paint a full picture and probably won't serve the stated business goal to predict quality within 0.5 points of how a wine expert would assess any given bottle. In our second workshop, we'll tackle how to improve upon this to make more accurate and ultimately more useful predictions. Before you join us for that, feel free to watch the full recording from Workshop 1 and download the provided data and code from the links below.